Okay, you know the feeling. You're about to run a migration on a live database, and that little voice in your head starts whispering, what if this goes wrong? Well, today we're going to answer that question. We are diving deep into the art of the database rollback, how you can design systems that not only move forward, but can also take a graceful step back when things go south.
Right, this is where theory gets terrifyingly real. A production database migration, it's like a high-wire act with no net. You've got millions of users, terabytes of data, and just one line of code that could bring the whole thing crashing down. And this right here is exactly why we need to have a serious talk about rollbacks.
So let's just cut right to it. The migration fails. Data is getting corrupted as we speak. The clock is ticking. What is your undo button? What's the plan to stop the bleeding right now?
And here's the cold, hard truth. For a live, stateful system, a simple undo is basically a fantasy. You can't just hit Control-Z on a dataset that's changing every millisecond without causing even more chaos. That's why you have to build your safety net before you ever step out on that high wire.
But hey, this isn't all doom and gloom, not at all. This is an engineering problem, which means there are engineering solutions. We're going to look at 3 battle-tested strategies for building systems that can handle this. Think of them as 3 different tools in your rollback toolkit. First up, we've got the expand contract pattern. Now, this is pretty much the gold standard for zero downtime migrations. The best analogy? It's like replacing an old bridge. You don't just tear the old one down. No, you build a brand new one right next to it. You slowly start redirecting traffic, and only when you are 100% sure the new bridge is solid, only then do you demolish the old one. It's incredibly safe, it's methodical, but you guessed it, it takes time.
Next up, feature flags. This is a super powerful technique that separates deploying your code from releasing the feature. You can ship the new database schema, you can ship the new code that uses it, but you keep it all hidden behind a simple switch. If anything looks off, you just flip the switch. The application instantly goes back to using the old code path. It's like a surgical strike, not a full-blown retreat.
And finally, there's the old classic backup and restore. This is your big red break glass in case of emergency button. It's a full system reset. And while it's absolutely crucial for any disaster recovery plan, you gotta know it's a blunt instrument. Restoring means you lose all the data that was written since that backup was taken. And that can be a huge price to pay.
So let's just lay it all out here. Each strategy has its trade-offs, right? Expand contract is the safest, almost zero data loss risk, but it's also the most complex to pull off. Feature flags give you an instant off switch, which is amazing, but remember, they don't undo the actual database change. And backups? Simple concept, but man, the risk of data loss is high and the restore is very slow. The right choice really depends on your system, your risk tolerance, and how much downtime you can actually afford.
Okay, to really get a feel for how this works in the real world, let's do a deep dive into the expand contract pattern. We're going to walk through a super common scenario and see exactly how this strategy gives you that safety net at every single step of the process.
I love this analogy because it just perfectly captures the whole idea. You're building a new, wider lane on the highway before you even think about touching the old one. Traffic just keeps flowing smoothly the entire time. You're not just hoping for the best, you're actively planning for the worst. That's the absolute heart of resilient design. So here's our example, a total classic. We need to split a single full name column into 2 separate first name and last name columns. It seems simple, right? It's a really common refactor, but it is a perfect example of a change that can cause a world of hurt if you're not careful. So let's see how expand contract lets us do this the safe way.
All right, let's get into the nitty-gritty. We're going to walk through the exact steps for this migration, from the very first schema change all the way to the final cleanup. And, most importantly, we'll see how at each step we have a clear, safe path to roll back if we need to.
Here's the plan broken down into 5 phases. First, we expand. We add our new first name and last name columns. The key here is they're nullable, so they don't break any of our existing code. Next, we start a dual write. We change our application so that any new or updated user gets written to both the old, full name, and the new columns. Then, we backfill. We run a script to populate the new columns for all our existing users. Once all the data is in sync, we migrate reads. So our app starts reading only from the new columns. And finally, when we're absolutely confident everything is perfect, we contract. We remove the old, full name column and the dual write logic. See? It's a marathon, not a sprint.
Now here's the beautiful part. At any point before that final contract step, we can reverse course without breaking a sweat. If we find a bug after migrating reads, no problem. We just reverse the process, we migrate the reads back to the old full name column, we turn off the dual write, and then we safely drop the new columns. Boom! It's clean, safe, and totally stress-free rollback. That right there is the power of designing for resilience.
So what's the big takeaway from all this? This isn't just about one little database migration. It's about a fundamental shift in how we think about building software. It's about moving from being reactive when things break to being proactive about failure from the very beginning. You know, here's something I've learned, often the hard way. Real, true resilience is never an accident. It is a conscious, deliberate design choice. You have to build it into your systems from day one, from the ground up. You can't just bolt it on later and cross your fingers.
So I want to leave you with this one question. As you're designing your next system, ask yourself, am I building a system that just works, or am I architecting a system that's designed to survive? The answer to that question will determine whether you've built a house of cards or a fortress. So, choose wisely.